In the previous example, we saw how we could calculate the probability of two dependent events. Sometimes we're more concerned about what's the probability of the conditional event, or we want to be able to find the conditional probability. So from our previous example, I want to derive this a little bit differently. We found that if we wanted to calculate the probability of dependent events, then we would run this calculation. Probability of A and B occurring, if they were dependent, would be the probability of A times the probability of event B happening, given that we know A has already occurred. Well, in this context, what we want to do is we want to focus on how do we calculate the conditional probability? How do we isolate on this and find the probability that if A has occurred, then what's the probability of the chances that B is going to occur? In order to do that, we want to just solve this equation, and to solve this equation, we want to get rid of this multiplication, and we can undo multiplication with division. So basically, we're going to rearrange this equation by using our equation solving skills. We're going to do the inverse of multiply and divide. The inverse of multiplying gives us an equivalency of 1 if we divide by piece of A and piece of A. And we'll have a final result of the probability of A and B divided by the probability of A equals the probability of B given A. Now that's what they derived and they solved for down here. There's nothing different in this down here, and that's the same idea that they're trying to present in the textbook. The only thing I think they maybe wanted to change is that they were going to solve for probability of B given A. So in our key concept box, we're going to look at how to calculate conditional probability. It's nothing more than our dependent probability equation rearranged. But if we want to find the probability that B occurs, if we know A has already occurred, then we'll run this calculation. The probability of A and B occurring divided by the probability of A. We cannot allow the probability of A to equal 0. If we allow A to equal 0, we're going to allow this denominator to be equal 0 no matter what this number is up here. Division by 0 is undefined. That's problematic for us, so that can't be an option. The second little context over here on the study tip would be independent events. What if A and B were really independent? If A and B were independent, then A should have no impact or bearing on the probability of B occurring. So if we take the formula that they have, the probability of B given A equals the probability of A and B divided by the probability of A. If A and B are independent events, we looked at this earlier in the lesson, that if they're independent, it's nothing more than the probability of A times the probability of B. So I take probability of A times the probability of B. They're independent, divided by the probability of A. As you can see, the probabilities of A's will reduce to an equivalency of 1, and the probability of B given A is nothing more than the probability of B. And if they're truly independent, there should be no impact or bearing on if A occurs, then B is going to follow without any regard to what happened with A's draw. So let's take a look at this example in our conditional probability example number 3 and see if we can apply that in this situation. At a restaurant, 25% of the customers order chili. If 4% of the customers order chili and a baked potato, find the probability that someone who orders chili also orders a baked potato. So in this problem, they're asked us to find the conditional probability. Right here it's saying, okay, find the probability that someone who orders chili, we know that they ordered chili, they will also order a baked potato. So given that language, we want to find the probability that they will order a baked potato given the fact that we know that they ordered chili. So this is our conditional probability that we're going to be looking at. So we're going to apply our formula that says, well, first of all, calculate the probability that they order a baked potato and chili. Then divide it by the probability that they would order chili. So we're following our formula, we're following the idea of conditional probability. So let's go ahead and let's see what we got for numbers. Do we have any significant number about the probability that they order baked potato and chili? And that is given here. 4% of the customers ordered chili and a baked potato. So that is nothing more than 4%, which has a decimal of 0.04, divided by the probability of them ordering chili. Well, at the restaurant, 25% of the customers are going to order chili, so we'll plug in the 0.25. change that to a decimal, and that's our conditional probability, which is pretty simple to reduce here. If you slide your decimal point twice, slide it twice, you're basically multiplying top and bottom by 100. It's 4 out of 25, or 4/25 of a chance. So you can convert that to a decimal if you like that look better. And if you do, that's about a 16% chance of getting someone who's going to order a baked potato if you know they've already ordered chili. So calculating conditional probability.